Hello students and welcome to my channel Maths Hub. So today in this video I'll talk about the Cayley Hamilton theorem. So what does the Cayley Hamilton theorem tell? It says that every square matrix satisfies its characteristic equation. So we have just done what is a characteristic equation in the previous video. So the characteristic equation is when we solve the determinant of a minus lambda I is equal to 0, that leads to the characteristic equation. So that characteristic equation is in terms of lambda. So we are saying that every square matrix satisfies that equation. So in place of lambda, when we substitute the value of that square matrix, that statement is called the Cayley Hamilton theorem, right? So let us see that how the questions on Cayley Hamilton theorem will come. So the question says that find the characteristic equation of this matrix and verify that it is satisfied by A, obtain A inverse, and then express this polynomial in a linear polynomial in A, right? So we have to first find out the characteristic equation. Then we have to see the verification part, that whether the square matrix satisfies that equation. Then we have to find its inverse, and then we have to reduce this polynomial into a linear polynomial, right? So let us do it step by step. So let us first step is to calculate the characteristic equation. So in my last video, I've told you the shortcut method of calculating the characteristic equation using the formula lambda cube minus trace of the matrix into lambda square plus sum of the minors along the principal diagonals into lambda minus determinant of the matrix is equal to 0. So do watch that video to check that method. And then when you frame the characteristic equation, we get the determinant of 2 minus lambda minus 1, 1, then minus 1, 2 minus lambda here, minus 1, 1 minus 1, 2 minus lambda. Since we are subtracting a minus lambda I, so only the diagonal positions are affected, right? So when we solve this entire equation, the determinant, we get our characteristic equation as lambda cube minus 6 lambda square plus 9 lambda minus 4 is equal to 0. So we could solve the first part of the given equation, the characteristic equation. Now we have to go to the verification part. Now Cayley Hamilton theorem says that every square matrix satisfies this equation. So when every square matrix satisfies this equation, that means in place of lambda, if I substitute the value of this matrix, that means a cube minus 6a square plus 9a minus 4. Now everything is in terms of matrix, so let me write the last term as 4 times I. So I should get this equal to 0. So let us try to verify it. So verification is simple. You have to calculate first of all a square. We multiply a 2 times, we get this matrix. And then we calculate a cube. We will multiply a square with again a and we get this matrix. And then let us put it back in this equation. And we can see that when we put these matrices in this equation, it leads to a null matrix. That means all the entries becoming 0. So this proves the Cayley Hamilton theorem, right? And now let's move on to the third segment of the question, that is to calculate the inverse. Now how to get the inverse of this matrix? Whatever equation we obtain after applying the Cayley Hamilton theorem, we take that statement and we multiply the entire equation with A inverse, right? When we multiply with A inverse, this will reduce to A square. The next term will reduce to A. This term will reduce to identity and we will have here A inverse, right? So we can retain this term and we can send all the terms on the other side. So we will get 4 times A inverse is A square minus 6A plus 9I, right? So we have just computed A square. So substitute that value. Subtract 6 times A and add 9 times I. So this is what I have done. And after doing that, we get the matrix as this. And A inverse will be calculated by taking 1 by 4 of the previous matrix, right? So you can see that with the help of Cayley Hamilton theorem also, you can calculate the inverse of a matrix, right? And then the next section and the last one, to simplify the polynomial, right? So we have this theorem, A cube, the Cayley Hamilton statement, right? So what we will be doing, it's very Whatever we have to reduce, we take that as the dividend. We have a6 minus 6a to the power 5 plus 9a to the power 4 minus 2a cube minus 12a square plus 23a minus 9i, and we divide this with our Cayley Hamilton theorem expression, that is a cube minus 6a square plus 9a minus 4i. So we multiply this with a cube first. When you multiply with a cube, we'll get a6 minus 6a to the power 5, then 9a to the power 4, and we get minus 4a cube. Let's subtract it. On subtraction, we can see that certain terms are getting cancelled, and we get here 2a cube minus 12a square plus 23a minus 9i. Now we multiply this with 2 times I, so we have 2a cube minus 12a square, then 18a with a plus sign, and then we have minus 8i, right? And again we subtract. So this reduces. 23 minus 18i will become 5a, minus 9i plus 8i is minus I, right? So now how to write this expression? We can write this as a6 minus 6a to the power 5 plus 9a to the power 4 minus 2a cube minus 12a square plus 23a minus 9i. This is the dividend. The divisor is a cube minus 6a square plus 9a minus 4i into the quotient, that is a cube plus 2i plus the remainder, that is 5a minus I. This is how we write. Dividend is divisor into quotient plus the remainder. Now you can see that according to the Cayley Hamilton theorem, this part is 0. So 0 multiplied by this is 0, plus we have 5a minus I. So this leads to the final answer, that is 5a minus I. So you had to express this as a linear polynomial, right? So this is a linear polynomial, right? So with the help of this question, you could understood what are the applications of Cayley Hamilton theorem. You can see that you can express a bigger polynomial in terms of a reduced polynomial. You can find the inverse of a matrix, right? So do try these problems, and in the comment section, if you have any doubts, do let me know. And those of you who have liked the video, do hit the like button. And those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video. Believe in yourself and you will definitely succeed, and do subscribe and do share the videos with the ones who need them. Thank you so much.